Test, test. Okay, so morning everyone. Hope you enjoyed the first day of OffensiveCon, and this is the second day. I will start with the keynote. First, I want to thank OffensiveCon and Miguel to invite me as a keynote speaker. It's my great honor, and today the topic is about changing and unchanged things in vulnerability research. Yet, how should on Twitter you call me Win Long, it's my nickname on the internet. So the origin of this talk, and last year I announced on Twitter that I would quit vulnerability research. Actually, in the past 15 years, I have been working hard and given many technique talks at various conferences, but except OffensiveCon. This is the conference I always want to come and speak at. But yeah, you will see my first talk is at XCon and the last talk at Mosaic. But after retirement, I got a chance to be here as a keynote speaker. So I'm so exciting at first, but later, when I just want to start to write a keynote, it's not easy. A lot of problems comes with it because I have no experience to give a non-technique talk. So I reviewed the past keynote talk in the OffensiveCon, and yeah, I will just give it a shot, and I hope you will like it. So this is the typical first page, right? Who am I? So to save some time, I just asked GPT-4 for the answer. Yes. Yeah, I just paste it here. So apparently the most famous work of mine was Pengu jailbreaks. Yeah, I'm the co-founder of the Pengu team and the main developer of the Pengu jailbreaks. I did keep working on the iOS, macOS vulnerabilities and exploitations, and from iOS 7 to iOS 15. Because I stopped last year, it's about 9 years. It's quite a long journey, focused on iOS. Also, before Pengu, actually, I already had much experience in low-level system development and some Windows vulnerability research. If you look at some early talks from me, I talk about some Windows vulnerabilities. Okay, back to the topic. So first, I'm going to share some what I have seen in this vulnerability research over the past decade, and let's start talking about the vulnerability research itself. Motivations. So I believe most of the researchers choose this career due to certain motivation, and I just list some of them. First, it's about getting freedom. So, for example, you want to unlock some hidden features by the vendor, or you want to get full control of your own device. You need to exploit and gain some privilege to do that. Yeah. And also, sometimes it's all about the challenge. So by breaking into the system, which claimed or believed to be extremely safe, you actually can prove that it's actually hackable. And this way gives you a great joy. Or maybe you just want to show the power, like you are much more capable than other people. In my case, it's about freedom at first time. So many years ago, after I switched to my first iPhone, which is iPhone 3GS, it's a very old one, but beautiful one. So I always wanted to have full control of my own device. The only way is to jailbreak it. That's how I involved in the iOS vulnerability research. And later, iOS actually becomes much safer. Then it's become a big challenge. Yes, this is about the challenge, a great challenge, and this also motivated me to do further research in the past 9 years. That's about motivation. So the process. A typical process of vulnerability research consists of 4 parts, I think. First, you need to discover bugs. And then normally you will try to write the POC to prove the idea or prove the bug itself. And then you may stop. Sometimes you may stop here because you figure out that the bug is actually not exploitable. But in other cases, you will continue to try writing exploit of it. And this step actually requires you to have more knowledge of the targets. For example, like you need to know how the heap works, the layout, and the management of the heap. And the last part is post-exploitation. No, so you got the exploit work, but you need to show it to somebody, like, for example, some contest. You need to demonstrate your exploit. So, for example, you will pop a calculator or a reverse share. But in most cases, this is not hard before, but it could be hard due to a lot of new mitigations, which we will talk later. Yeah, here I use the word post-research. So post-research refers to, so for the researchers, when you have the work done, what will you do? First, if you success in your research, so you have some achievement, let's say the exploit works, so it could always be a double-edged sword because first, it could be used by criminals. It's just like a weapon, or vendors could learn from the techniques involved in it and improve the security level of their products. And from my view, that I feel when I was focused on the research work itself, it's actually very lonely in my view, because for a long time you just facing these all 0 and 1 digits. So after the work, you need to find a way to relax or refresh. So communications are essential in my view, like going to the conferences. That's why a lot of people coming here. So through sharing your research, you may relax, make friends, and also you may inspire some other researchers, right? For me, example, I think it's about 2007. That's the first time I attend a security conference, which is XCon in China. And it motivates me a lot. So the next year, 2008, that's my first technique talk at XCon also. Yeah, I think that's the power of communication, and that's why during my research work, I keep sharing my work at various conferences. Okay, that's about the vulnerability research. Now let's start to see. So what's changing in the past years? If any of you have already been involved in this field for a long time, you can try recall how you discover bugs in old times. I think it's around before 2000. Most bugs are actually just overflow bugs. So at that time, when you are auditing the code, you just need to inspect the code around the memory writing, like you find the reference of the memory copy function, and then you check out the length of the source and destination buffer size, and if you're lucky, you just got a buffer overflow. And it's not hard to find bugs in that time, because first, the developers, most developers had no idea of secure development. So they don't have the idea of exploit or overflow. And also at that time, compilers have no security features to detect potential overflows. Yeah, but also in old time, when you are doing a lot of auditing and you realize that manual auditing is too much work for some large code based software. So the idea first come out naturally. By feeding the software with random input, we could test if the code are vulnerable or not. At that time, I also managed to write a very, very simple fuzzer. So you just just try to download as many as valid samples from the internet, and then you flip 1 or more bytes of it, and then you feed it to the targets like Flash, Office, or PDF, and then you will have many crash logs at that time. Also, there comes the programs analysis tools. So if you have done code auditing a lot, you must have struggled to track, for example, where the variables comes from. Maybe it's not direct function call, so it could be exhausted and very hard. So in some cases, the program analysis technology could help you. So by using this technology, actually there's a static code analysis tools. There's commercial tools like Coverity and 45. And now these tools are actually used to scan the source code and kill a lot of bugs during the development stage. That's before you release the software. Yeah, but at that time, it could find a lot of bugs. Yeah, that's good old times, but things changed very quickly in past few years. First, a lot of things happened in the defensive side. Like the developers are trained to follow like secure code standards. Yeah, you always initialize variables. You always use safe version functions like memcopy underscore s. And the second, more and more security features were added to compilers, like detecting potential bugs and mitigate certain exploits like Stack Overflow. It doesn't work anymore. Also, Microsoft proposed the SDL. And more than this, recent new programming language like Rust, so it's designed for security. It's the purpose is to it enforces the memory safety naturally. So to exploit, yeah, I remember recently the Win32K. Yeah, it's a very bad one because a lot of bugs in it is recently rewritten in Rust. So for the offensive side, we need to like put eyes on more different kinds of vulnerabilities. It's not just buffer overflow like old times. So yeah, at least some of them, like TOC, TOU, and logical issues, type confusion, yeah. Also, a simple fuzzer like before is now useless. So researchers are introducing many new techniques. It's alarming for what? So researchers are introducing many new techniques into the advanced fuzzing. A lot of them are coverage guide. Again? Okay. I say something wrong? Okay. So, yeah, we now have many powerful fuzzing tools like AFL and Pitch, like coverage guided, let you know if you coverage most part of the code to test them vulnerable or not. And also, some tools are target specific. So for better performing, for example, the Fuzzy is for the JavaScript. Now I will share some recent bugs that I think which are interesting and innovative. First of them is the kernel bug used in the Fugu 14 jailbreak from Linux Hints. The bug itself is in the driver kit method, so it actually requires you to get root privilege first to exploit it, but it's okay. We just take a look at the kernel one. So you see the code here. The function actually before calling the with address range didn't check if the f task could be none. So when the f task passed to the with address range function with 0, if you take a look at the brief of the function, you will see the function will return a memory descriptor for you, which is used for physical memory access. Yeah, that's very simple. You even don't need to like know the heap or something exploit. It's just very easy. So this is a simple one, but very powerful. But because you have direct access to the physical memory. So from the lesson is that for developers, yeah, you follow the secure coding standards, but you always need to fully understand the APIs you are using. Yeah. Okay, the next one is a very charming one. Yeah, this is the ASN.1 decoding bug found by Sharab. As we all know, the image files of iOS actually are using the ASN.1 encoding, so it allows you to get code execution by parsing a malicious image file. Sharab gives a detailed write-up on the internet. So yeah, just take a look at the buggy code. The buggy code is when parsing bit stream. So this bit stream is a kind of object in the SN.1 standards. So there's a shortcut for handling a very special kind of bit stream with only have 1 byte. So this 1 byte is used for unused bit count because it's bit string. Like I need 1 byte to tell how many bits are actually not used, but this is actually 0 because there's so only 1 byte. So there's a shortcut for it. In the shortcut, it will know out the data pointer. This pointer is supposed to be a pointer to points we call the there pool heap, but it's a very complicated state machine. So somewhere else, when somewhere else found that the data pointer is none, it will points it to our heap, and this time the allocation size of the buffer is actually wrong. It's smaller because it should be there's a lot. Maybe there may be more data to process. So in that cases there will be a heap overflow. This kind of state machine bug is very hard to find. I think, like by fuzzing or by manually auditing, both hard. Yeah, you need to deeply understand how the state machine works. That's why the bug is so charming. Okay. And yeah, Imbir is here and he talked his bug yesterday. So yeah, this is a very cool one. It's because by race condition, it just allows you to read only mappings, very powerful. And I believe discovering this kind of bug requires like deep understanding of the code and the logics behind it, the designs of the developer. Yeah, but you already know the details in yesterday, so I will just skip it. Okay, the last one is a recently fixed bug in 16.4.1. This bug was exploited in the wild. And there's a tweet from Linus Hans, shows the patch and also the POC of it. If you bind it yourself, you will see there are actually multiple size checks added in the iOS service accelerator related functions. So this is actually reachable from the web content, so you can just exploit it in the browser. But this bug is, yeah, you may miss this bug when you're auditing the code yourself because it requires a lot of reverse engineering work, I think. The buggy code lies in an async function, so you need to find the function, and also the source buffer, the length of the source buffer was allocated during the initializing of the user client object. Yeah, but anyway, no size check in 22.3. I don't think. Yeah, I think Apple should maybe improve the. Yeah, should no classic buffer overflow like this still in 2023. Okay, post or exploitation in old times. So the target is always to execute arbitrary code, like yeah. So before it's quite easy job for Stack Overflow bug. Yeah, you just need to override the return address and jump to the pre-stored shellcode. For heap overflow bug, you could try to find some function pointers to override, or you just could hijack the free list. And for browser, after you get the right operation, you can just put a shellcode, write a shellcode into the gem memory, and then jump to it. At that time, no actual post exploit needed. So this is in recent time. So at that time, from Jet code, basically you could do anything you want. Like you just write a payload on the disk. There's no sandbox, and then you directly load the payload. There's no signature validation, and the payload can do anything. Yeah. So in recent time, things changed dramatically. More and more new mitigations are introduced. And here I would just give some briefs of it because, there's actually a very good talk by externalist at the DCS ZeroCon. And there's a huge details in his slide. So, yeah. So here, mitigations. I think all of you are very familiar with them. Yes, and so among them, the enhancement of heap actually keep changing very quickly. So it's not like the stack cookie, you introduce it and it's over. So enhancement of heap. Ideally, the address of heap should be randomized, and different objects, heap objects should be isolated, so you don't do like type confusion. And with now with the 64-bit addresses, you should it's better not to reuse the freed virtual address because you have enough address space. So that will prevent the use of free because you can never get the same virtual address. Also, remember to zero out the memory before allocation and after deallocation. Yeah, that's also very important. So that's some general mitigations, and there are also a lot of mitigations, especially from Apple. Yeah, I just put the name here. The main targets behind those protections, the targets to protect are actually like pointers, include the function pointers, heap pointers, kernel code, jet memory, and important kernel objects like page table. And the last one, the MTE, it's hasn't come out yet. So finally, now it's time for jailbreaks to Twitter and ask Apple why ETA. Okay, so in addition to those mitigations, vendors are designing more secure architectures for their products. You see there's a sandbox, code signature validation, and TCC to control the access of different apps, and SIP to protect the root system files, and the TEE, SAP, data protection to protect user privacies. Secure boot chain is the root of the trusted system environment. Lockdown, of course, lockdown mode is for those who are extremely concerned about security, like me at OffensiveCon. Yeah, because the first day I arrived here, I found my springboard actually respring. It's very weird, and then I realized this is a very dangerous place. So I turned on the lockdown mode for the first time. Yeah, so with all those mitigations and new secure architectures, so what a typical one-click attack looks like now? First, you will need you always need to exploit Safari to get arbitrary address rewrite in the browser, and then now you need to bypass the userland pack to be able to copy your shellcode into the jet memory, and with the jet cage, you also need to find a way to bypass it to call the APIs you will need for the next exploit. If your kernel bug is not reachable directly from the browser, so you will need also try to escape the sandbox first. And after all those steps, now you can finally export the kernel and get the arbitrary address rewrite in the kernel, but it's not end yet. You need to bypass the kernel, the pack in kernel to call arbitrary functions in kernel, and then you will the last step, you will have to bypass the PPL to control the page table. After control the page table, finally you have fully control over the kernel heap. Like there's a lot of read-only memories now, you cannot change. Yeah, so that's finally the end of the story. You see, it's very, very complicated. Now time for share some cases of bypassing. So first to talk about is about KPP. Yeah, this if you ever investigated in this one, you will find that the design of it is a little bit weird because there's a large time window allow you to like patch the code first, execute it, and then restore code. The KPP will not detect that. So basically, KPP is not working as expected. It was, yeah, of course, it was deprecated later, then replaced by the KTR protection on newer hardware. Yeah, from this lesson, because from the offensive view, we think this is totally useless mitigation. So from this lesson, we can see that designers of these security features, they must have knowledge of offensive techniques. So yeah, there's actually an old Chinese saying for that. It means if you don't know how to attack, how could you know how to defend? That's the meaning of this Chinese sentence. Yeah. Okay, and I think Apple realized this very quickly, and yeah, they had a lot of formal jailbreaks later, and okay, the next one, pack in kernel. So Brandon Azad shared 2 great talks in 2019 Mosaic and 2020 Black Hat, which introduced about like 10 ways to bypass it. Yes, it's about 10 ways, but there are actually more ways to do that. So I just list some of them. Yeah. So among them, one is very interesting. It's the 5th one. Yep. When an auth instruction fails, it doesn't throw the exception. It just put an error code in the pointer, and when you try to use the pack instruction to send a pointer with error code, it just works. So there's an attack mentioned. So to fix this, it was improved on new hardware because the auth and pack instructions, Apple cannot update how the instruction was on old ones. But for the old hardware, there's a software fix for it. So you will see if you look at the code, so after each auth instruction, there's always a compiler. If there's error code in it, it will throw an exception. Pack in userland, first we talk about the browser. There's also a good talk about it by, sorry, my bad, at Mosaic 2021. Yeah, in the past there are a lot of zero context signed function pointers used in the userland, but so the attack could just replace all of those functions because they are all signed by zero context. So in that you can like to put them together for some like gadgets, but now Apple removed most of them, and you will see that they intend to use different context values everywhere. And another bypass here is by racing with the JIT compiler thread, and you can actually replace the JIT code to be written into the JIT memory. Then Apple add JIT signature to prevent this. Additionally, Apple also will mark, now there's some objects should be like one-time initialization, but it should not be changed after it's initialized first time. Yeah, Apple will mark these objects as read-only. So this prevents an attack like corrupting the signal handlers. And the pack in userland should also protect the sandbox escaping bar. But for a long time, the A keys are actually same across the process, which allow the attacker to forge a rob chain very easily. But now Apple realized that and forces like Safari and user apps to use different A keys from system demos. So if you want to build a rob chain for the system demos, it's not possible because if you don't know the A key. So this makes sandbox escape much harder. And besides that, so if a demo crashed and different A key may be used after a system automatically relaunching it. The last one about the PPL. So yeah, there's a bypass by the Linux in the Fugu 14 jailbreak. There's a PPL bypass. So per request, of course you need to have be able to call arbitrary function first. Like you need to call the PPL function. And there's one function allows you to map the physical address to a virtual address. Of course, there's some checks in it. The check is very directly the physical address you want to map should not belong to the PPL protected memory, like page tables. So that's check for the physical address. But Linux realized that the physical address on the 64-bit devices actually only supports 48 bits addresses. So if you look at the code of how it checks the physical address is valid, it just compare with the range of physical address. So if you set the high bits of it, it will pass this macro. And if you look at the code, actually, when you create a mapping, it will still works, because in the process of create mapping for it, it just ignore the high bits of it. So basically, there's no check if this is valid physical address. I mean, some high bits should be 0, right? Okay, so yeah, after you set the high bits of like a page table physical address, you can map it to some virtual address, and then you can, control the page table, and then the game is over. Yeah, that's the PPL bypass. Okay, some conclusion. So you will see, obviously, there are more bugs needed to build a full chain, and I think it's extremely hard now for one person to build a full chain by himself. And the mitigations killed a lot of previous exploited bugs. Yes, so maybe among 10 bugs, there's only 1 or 2 bugs exploitable now. And bypass of mitigations is actually more valuable than the bug itself. Yeah, because the code base of the mitigation are actually very small. So yeah, finally, if they don't introduce new code into this feature, then there won't be much bypass. Okay, so also hardware supported mitigations have become very popular in these years, but they have pros and cons. Pros is that its efficiency, powerful, and it's totally black box. The cons is that if there's a design flaw, if there's a weakness in it, you cannot fix it because it's in hardware, right? And logical bugs are actually much more powerful now. Anyway, mitigations are designed and written by human beings. Yeah, human beings make mistakes. That's why we have all those bypasses. So, yeah, what's not changed? The techniques involved in the vulnerability security are constantly changing, and the changes are getting faster and faster. But yeah, in my view, that's the vulnerability research. You could look at it as a game between the offensive side and defensive side. It's just like maybe a CTF game, but the difference is that the targets are real products used in daily life. And yes, both sides in the past years, both sides keep upgrading their arsenals. Like the attacker is weaponized with new tools like FL, Hex-Race, decompiler, and also you have Column virtualization platform for debugging. And on the other hand, the defender also is upgrading their software, hardware, and there's a lot of new mitigations. So it's the competition between both sides, but not changes that the people involved in this game are not changed, in my view. So, yeah, but people may change their perspective. For example, there are some good researchers from offensive side, they may move to defensive side. Yeah, like Brendan Azad, I mentioned, he talked about pack bypass before, but now he worked at Apple and tried to make the external kernel more safe. Yeah, it's always in my view, it's always a competition between those researchers. And this actually, yeah, I talked with Luca yesterday, and he told me this actually motivates him more to win this game because it proves he is better than the other side. Okay. And yeah, you see, researchers are the key points in this game, and the requirements to be a top researcher, I think, is always the same. It's not changed. You need to be smart first, and then you have passion for what you are doing. You also need to tolerate failure because to get and exploit what work or to find a bug, failure is inevitable on the road to success. So never give up until success. And yeah, the last point, I think maintaining, integrating is quite important in this area, and it could help you to stay on the right path for a long time. So last one about future. So the techniques change constantly and maybe change faster, but yeah, and you will see for the new players in this field, it's like not friendly anymore. Like years before, you have a lot of things to learn, but yeah, but we still need new blood in this field because yeah, like me, I just need to stop my research at a certain age, right? So you always need new blood. We still have chance to win the game. The offensive side still have chance to win the game because the opponent is still human. But yeah, we never know in the future what will happen because yeah, the AI is changing quickly. Also, maybe in the even far future. Yeah, and at the end, there's a talk I want to talk about it. Yeah, I'm personally a fan of MMA, and I like watching UFC game. So yeah, this black guy here is he's Adesanya. So he got revenge on the opponent Pereira and reclaimed his belt, and that's what he said in his interview. So you will never feel this level of happiness if you don't go for something in your own life. So I will give those words for the people who think the research work has become too difficult or impossible to do. You need to go after it. Then you can feel the happiness. Other people cannot feel it. Yeah. Yeah, and that's my keynote part of talking. And yeah, I did try hard to think of more to talk. Yeah, because like I promised Miguel, I want a 1 hour talk. Yeah, and OffensiveCon is a conference I always want to come, and it's a highly technical one. So I start searching in my memory to see if there's any tech topic I can share. And here we go. Yeah, I will talk about some missing part from my last tech talk, which is 2020 at Mosaic. So this is my last talk is about attacking the secure boot of the SEP. I think this is the first and the only published bug for the Apple SEP. Yeah, and after I shared the topic, and little Lilo, I don't know if he's here or not. He messaged me that he also found a bug, and with his suggestion, we named it as Blackbird. So yeah, this time I also put a logo here, and thanks to mid-journey, the power of AI. Okay, so there's actually a missing part of it. I will cover it here. So a quick review of what Blackbird is. So I talk about two issues in the slide. The first one is that by manipulating the T0, which is trust zone 0 registers, it allows the attack to bypass the memory isolation. That means from AP side, you could access the encrypted SEP memory. This affected AA to A10 devices. And the second bug I talk about is the SEP room code is putting the key, the seeds for the key on the shared memory. So if you can access this memory through raising these seeds, you can force the SEP to using fixed AES key for memory encryption. That means with certain plaintext, the cipher text will be the same every time, even you reboot it. So that's how you can partly control the SEP room memory. And in my talk, I actually showed a demo here. The demo is a demonstration for brute forcing a passcode of an iPhone 6s, on the mosaic. So actually, behind the demo, I managed to load a patched SEP OS that removes some limitation. And after I published my slide on Twitter, and a month later, Chickering released the exploit for the exploit of Blackbird for iPhone 7 devices, because Apple tries to kill Chickering in iOS 14, right? Yeah, iOS 14. Okay, so the exploit from Chickering is included in Pango OS, which is open sourced on the GitHub. I don't know if you have take a look at the source code. I would just give the rough exploit steps of it. So to ask the SEP room to load OS, you need to send an image file to it. Yeah, of course. And there's a special image part in the image. It's called IM4R. This part is like for the restore usage. So you can just put it together, but if it's not used, it will not. You don't need to verify this part, but it still will be copied into the memory because you told the SEP room to load it. So attach a fake IM4R at the end of firmware. There's only one instruction in it. It's like 4 bytes. It's load PC to address in hex 0OEO40. Okay. And then on the AP side, we put the share code we want to execute on the SEP at address 210EO40. And then we try to send the boot TZ0 message to SEP, and the SEP will initialize the encryption memory and in the shared memory ready for the loading the SEP ROM or SEP OS. At that time, all the memory are actually zeroed. Yeah, because it's a good habit. You initialize the memory to 0 at first. So you keep a copy of those memory, but those memory are all zeroed memory, remember. Okay? Now you try to ask the ROM to load the SEP OS. You send the image file to it with the attached instruction at the end of it. And then after the SEP ROM verifies everything is okay, before jumping to the SEP OS payload itself, the SEP will send a message back to AP. At that time, I do a memory replay attack. I put 0 out all the SEP memory because I know the encryption. What's the 0 memory looks like in encryption, right? I 0 out all the valid instructions, 0 out the payload, and when the SEP before jumping, SEP will actually turn off the MMU and jump to the payload. So there's no any protection at that time because the MMU is turned off. And now the payload starts with all 0, but 0 bytes is actually a valid instruction in ARM v7 and with no harm. So you can just execute all these zeros until, because we don't override the block contains the load, the 4 bytes instruction for load PC. Okay, so it executes all zeros until the last instruction, which at the end it sets PC to the hex D0E040. And actually this address contains the shell code we put at the AP side. Okay, so I didn't get this first, so I asked Luca, and Luca told me that because from the aerospace, so these two addresses from the aerospace, they're the start address of the SRAM. So from aerospace, you can access both of them from AP side and the SEP side. Yeah, and when I reviewed this exploit, I realized that one thing I didn't know before, that SEP has only one channel for memory encryption for A10 devices. If you look at my slide, that for A9 devices, that's iPhone 6s, before jumping to the SEP OS, it will create another channel for encryption. It will derive keys again from random seeds and then use another encryption. So yeah, so I really doubt this exploit will work against iPhone 6s because you don't have the large time window to replay a lot of zero memory in this case. Because before jumping the SEP OS, it reinitializes all the keys used in encryption. So, anyway, my exploit worked for the iPhone 6s, and I actually there's a slide. This is from my last slide, and I talk about the way I try to exploit it. I don't know if anyone tried it and anyone can success. So, yeah, my way to exploit this is trying to replace the SEP OS the SEP OS payload. So remember, we could always force the SEP room to use the fixed AES keys, so the memory is fixed. That means we could if we want to know the encrypted bytes for certain plain text, we could dump the encrypted memory to know that. So yes. So before jumping to the SEP OS switched to another encryption channel, but there's still a time window for us to raise SEP firmware memory. Yet, before that, so there's a lot of choices. To figure out what we should do, we need to reverse engineering how the SEP ROM load the SEP OS. Yeah, I just give the steps here. So it first copies SEP OS firmware into the encryption memory, and then verify of course there's a signature and certificate in it. It verifies the signature and the certificate. It's from Apple, and then it load the properties from the manifest information. It includes a lot of the properties like e-key, digest for the payload. Okay. And there's also CHEP, ECID, and S-nonce. S-nonce is the nonce for SEP. And then it check the hash of the payload with the digest value to see if they are the same, and then retrieve the keybacks for decrypting the payload and verify these properties, like it must be like the chip ID is right for this device, something like that. And then I check the hash of the manifest, and again set up another memory encryption channel for SEP OS. When it's ready, it will. Oh, sorry. When it's ready, it will rewrite the whole firmware into the new encryption channel. And before finally jump, it will check the hash of payload again. Okay, so yeah, after I learn the steps to load the SAP OS, I need to see what can I do. So first, I noticed that to verify a signature and a certificate chain, it's a time-consuming operation, right? So yeah, and then after rewrite the firmware by new encryption channel, because this time the random seeds are not in the shared memory, so we cannot force the SAP to use a fixed encryption key in this second channel for SAP OS. So we will lose control of memory at this point. But still, we have a large time window to patch anything in the after the signature and the certificate verification. You have a large time window to change a lot of things here. But we know that after rewrite the payload into the new encryption channel before jumping it, it will actually check the hash again. So if we want to load the arbitrary SAP OS payload, we also need to modify the digest value because it must be matched. And there's actually a big problem here because there's also a check of the manifest information because the digest value are retrieved from the manifest, but there's a check of manifest. So yeah, if this check fails, like you cannot raise to modify the digest, it will fail, right? So what I do next is I try to figure out how the hash of how the manifest was checked actually. So yeah, there's a very weird verification logic in this chart. Yeah, you can take a look at it. So typically, it will first check the boot type. So for device, it may be a normal boot, or you just want to restore your device, right? So for the normal boot, the device knows the device will read some stored manifest hash for booting. It's the hash for booting, and this hash must match with the hash of the manifest from the firmware, right? This makes sense, okay? And this logic actually is simple and it works. I mean, okay. On the right side, it's the process for the restore operation. Okay, so if there has been a nonce already generated for the device, that nonce is the random bytes used by Apple to control if you could upgrade to certain firmware or not, right? Okay, so if there's a generated nonce, it should check if the nonce is correct from the firmware you are trying to restore. But if there's no nonce from the manifest, it just directly goes to allow this function. You see the issue here? It's very, very weird because there's no nonce included in the firmware you send to the SAP. It allows it. Yeah. Anyway, that's the very weird issue I found. So to bypass this manifest verification, it's quite easy. So when AP told SAP to boot the OS, it told it to it sent a message with the restore flag, so it goes to the restore process. Okay. And another thing we need to do is force decoding of nonce to fail. So let's check the code here. This is the code from the SAP room, and it tries to decode the tag as nonce with appropriate data. Yes, SNAS must be a data. So the easiest way to raise it is to flip one byte, like you can change the type of SNAS, like to a number or anything you want. Yeah, the type is wrong, and the function will fail, and the has-not flag will not be set. So in that case, if we back here, so we don't have we don't have to care about the check hash of manifest part anymore. So there's a large time window for us to like raising. We can change the payload here, change the right digit value, matched with the payload hash. Okay. Yeah, takeaways. So yeah, a logic flow alone could be harmless, but when combined with some other bugs, it could save you lots of pain. And the code of Room better be flawless, but because if it goes wrong, the bugs cannot be fixed like ever. And I suppose that yeah, for Apple, there's a lot of places need to like to parse the image for file, right? And like for example, secure room from AP, yeah. But why? I think there's a different code implementations for the same function. And like for the AP side, the secure room works fine, but I don't know why the SEP side, the code works like that. Yeah, that's the takeaways. And now that's the real last slide. And yeah, first thank you. And I have to announce that Mosaic will be back. Is back this year internationally. Finally, after 3 years of COVID pandemic, so it will be held in Shanghai in late September this year. And the Penguin and the POC crew will be there waiting and welcome you. And yes, it's the same hotel as before. I know some of you may ask me this question. Yeah, it's the same hotel. And of course, there will be a BaijiuCon with it. And this is the Chinese version of WhiskeyCon and hosted by Thomas Lim. If you are interested in attending or speaking at Mosaic, you can just reach me on the Twitter. We can talk. And last, thanks Jonathan and Dave for reviewing my slide last night. And yeah, thank you again, and I hope you enjoyed the talk.